China's newest stealth aircraft, J-35, J-36, J-50, and more, can be summed up in two big advantages: integration and coordination. These jets weren't designed as isolated platforms, but as connected elements of a unified aviation system. In this video, we explore how China is building an air network where fighters, drones, and command aircraft share data, support each other, and why this shift is transforming the future of global aviation. China's latest lineup of stealth aircraft stands out not because of one groundbreaking jet, but because of how many breakthrough platforms are emerging at once. Each model fills a very specific role, creating a layered structure of capabilities that form the backbone of what observers now call a new generation aviation ecosystem. The J-35 is the aircraft most people recognize first. It's a fifth-generation, twin-engine stealth fighter built by Shenyang, with smooth aerodynamic shaping, serrated paneling, and an internal weapons bay to reduce radar reflections. Unlike older Chinese fighters, the J-35 was developed from the start to serve as a multi-role platform, capable of gathering sensor data, performing precision operations, and coordinating with nearby aircraft through secure data links. Its sibling, the J-35A, includes reinforced landing gear, corrosion-resistant components, and folding wings, allowing it to operate from aircraft carriers. Alongside the J-35 is the emerging J-50, a tailless experimental stealth jet that has generated global interest due to its unusual design. Images show a smooth, compact fuselage with angled control surfaces and what appear to be thrust-vectoring exhaust nozzles. This configuration suggests a focus on agility, low observability, and energy-efficient maneuvering at high altitudes. Because the design closely mirrors concepts explored in next-generation aviation programs worldwide. Analysts believe the J-50 may serve as a prototype for a future long-range, highly autonomous platform capable of operating in highly monitored environments. Then there's the J-36, a much larger, heavier aircraft with a distinctive tri-engine setup and a wide, blended fuselage. This design is extremely rare in modern aviation. The three engines increase range, payload, and endurance. Combined with side-by-side seating, the cockpit layout supports mission coordination, making it suited for controlling future autonomous aerial partners. The aircraft's dorsal air intake and angled surfaces help reduce detection, while the large internal volume likely accommodates long-range sensors, fuel, and next-generation equipment. What sets the Ghost fleet apart isn't simply the presence of new stealth aircraft. It's how these platforms are designed to work together. China's approach moves beyond the traditional idea of standalone fighters and instead builds a coordinated system where each aircraft contributes data, coverage, and specialized functions to support the larger network. At the top of this integrated system is the KJ-3000, a large airborne early warning and command aircraft. It carries a powerful radar array capable of monitoring wide areas, detecting distant objects, and acting as a real-time information hub. Instead of each aircraft interpreting the environment independently, the KJ-3000 distributes a unified picture of the airspace to nearby jets and drones. This shared awareness enables stealth fighters to make faster decisions, conserve energy by minimizing radar usage, and maintain consistent coordination even across long distances. Alongside it, the WJ-700 high-altitude drone adds persistent observation. Its long endurance and ability to carry a range of sensors allow it to hover above an area for extended periods, gathering continuous data. Thanks to its design, it can remain airborne far longer than crewed aircraft, ensuring there are no gaps in coverage. This information can be routed back to the KJ-3000 or shared directly with stealth jets operating below. The J-35, J-50, and J-36 serve as the fleet's frontline assets. Each carries advanced onboard sensors, including infrared systems and radar-absorbent structures that help them collect high-quality information while staying low-profile. When these jets receive data from drones and command aircraft, they don't need to reveal their position by using their own sensors as frequently. This approach improves survivability and increases the effectiveness of stealth technology. Integration also applies to communication. Modern aviation increasingly relies on secure, high-bandwidth links that allow aircraft to exchange information almost instantly. Although the exact specifications in China's systems remain undisclosed, consistent appearances of new antennas, data links, and sensor configurations on recent prototypes indicate a strong push towards seamless networked operations. The emergence of China's Ghost Fleet has drawn global attention because of what it represents: a shift from incremental aircraft upgrades to a large-scale transformation of aerial capability. This development signals a new era where advanced aviation relies heavily on integration, stealth optimization, extended range, and coordinated sensing, qualities that could influence how major powers evaluate and prepare for future skies. One major reason this matters is scale. For decades, developing multiple stealth aircraft simultaneously was considered technologically and financially demanding. Yet China is now producing a diverse set of platforms, from lightweight fighters to heavy, long-range prototypes, within a short time span. This acceleration suggests major investments in design automation, advanced materials, radar-absorbing composites, and high-precision manufacturing. When these techniques mature, mass production becomes achievable, leading to widespread deployment instead of limited elite units. Another reason is strategic reach. Aircraft like the J-36 and J-50 appear designed with extended ranges, large internal bays, and advanced energy management. These characteristics allow them to operate across wider regions without relying heavily on ground support or repeated refueling. Longer endurance combined with stealth shaping means these aircraft could maintain a presence in distant locations while staying less detectable. This shift impacts how nations think about early warning systems, monitoring, and defensive planning. The fleet's emphasis on data sharing also carries broad implications. Integrated fleets reduce the need for each platform to operate its own sensors, minimizing energy consumption and exposure. Distributed sensing, where drones gather information and stealth fighters act on it, challenges traditional monitoring approaches. The rapid appearance of new platforms also demonstrates a willingness to iterate quickly, test new configurations, and explore unconventional layouts like tri-engine heavy jets or tailless airframes. This agility gives China the flexibility to adjust its direction as new technologies and design insights emerge, closing gaps that once took decades to address. Finally, the continuous unveiling of new prototypes suggests a fast-moving development cycle. Instead of waiting for a single next big aircraft, China is evolving its aviation capabilities through multiple parallel paths. This strategy allows experimentation, adaptation, and refinement, all while maintaining steady progress. China's Ghost Fleet shows that the future of aviation is no longer about individual aircraft, but about how those aircraft connect. Stealth, range, and sensors matter, but integration is the advantage that ties everything together. With platforms like the J-35, J-36, J-50, KJ-3000, and WJ-700 forming a unified network, China is shaping a new model of aerial capability built on coordination, data sharing, and extended reach. As these systems mature, they will influence how countries design aircraft, manage airspace, and rethink the next decade of flight technology. The real story isn't just new jets, it's the connected ecosystem behind them. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, SpaceEyeNews.com. Thank you for watching, and see you next time.